In the spring of 2025, ocean buoys stationed along the equator began reporting something the models hadn't forecast. The eastern Atlantic, normally the planet's quiet water, was warming again. Not in response to El Niño, not as part of a seasonal swing, but through a slow, deliberate build that had begun years earlier. By July, sea surface temperatures near 10 degrees west were 2 degrees above average. The St. Helena High, the great anticyclone that drives South Atlantic trade winds, had weakened to its lowest recorded pressure in 40 years. Satellite scatterometers showed a 20% reduction in wind stress across the subtropics. The Atlantic's cold tongue, the narrow band of upwelling that feeds the West African monsoon, was failing. This is the Atlantic Niño, a cousin to the Pacific El Niño, but smaller, quieter, and until recently, largely ignored. A new study from Beijing Normal University and the Ocean University of China reveals it's no longer just an interannual event. It now runs on a 12-year heartbeat, a decadal oscillation originating not in the Pacific, not in the North Atlantic, but deep in the South Atlantic itself. During its warm phase, the ocean's cold tongue begins to heat. That heat spawns an atmospheric Rossby wave, a long ribbon of disturbed air pressure that arcs west to east across the subtropical Atlantic. The wave weakens the St. Helena anticyclone, the same system that powers the southeasterly trades. With weaker winds, less cold water rises from the deep. The surface warms further. The feedback tightens. Researchers found that in this mode, evaporation intensifies over the southwest Atlantic, cooling waters near 30 degrees south while the equator keeps warming, a pattern known as the South Atlantic dipole. The entire basin begins to breathe in opposite directions every dozen years, one lobe heating, the other cooling. For the people living under the intertropical convergence zone, that rhythm matters. When the warm phase peaks, the ITCZ shifts south. Guinea and Sierra Leone flood. The Sahel dries out. Maize yields fall. Reservoirs in Mali drop meters in a single season. Mediterranean rainfall increases at the same time, reshaping jet stream routes that steer European storms. The cycle then flips. Thermocline displacements, slow waves of density moving through the mid-depth ocean, propagate eastward between 3 and 15 degrees south, resetting the system. The cold tongue cools again. The St. Helena High rebuilds, and trade winds recover. The process repeats. It's an autonomous machine, a self-sustaining oscillation. And that's what alarms climate scientists most. In the models, greenhouse warming isn't required for it to exist. But when warming is added, the loop strengthens. Upwelling falters further. Rainbelts move farther off their historical lines. Predictability shrinks. In past decades, West African droughts could often be traced to Pacific ENSO events. Now, they may arrive from the South Atlantic instead, without warning. The team's simulations show that if the next positive phase begins in the early 2030s, the Sahel could see multi-year rainfall deficits independent of any Pacific influence. At the Italian National Research Council, oceanographer Chung-Shui Yang summarized the concern in one sentence. The South Atlantic is no longer a passive basin. The data agree. The subtropical cell transport, measured near 10 degrees south, has already fallen nearly 1 sverdrup below its long-term mean, equivalent to 1 billion cubic meters of water per second no longer reaching the equator. That shortfall means less nutrient upwelling, warmer surface waters, and greater instability in the region's marine food chain. In the coming years, a coordinated network of moorings and Argo floats will monitor the thermocline depth and Rossby wave propagation to test these findings. For now, the pattern remains intact, its last reversal dating back to 2013. If that clock holds true, the next warm phase will crest before the end of this decade. That's the timeline. That's the pulse of the South Atlantic.